Multisoft Virtual Academy, with over 21 years of experience, offers 1,500 plus courses, partners with 10K plus experts, serves 2,000 plus corporates, has trained 1 million plus individuals, and earning a 4.5-star rating. Here we share the overview, benefits, and facts.
So let's discuss the first pillar, which is capture. Okay. So as I mentioned, HVR specializes in log-based CDC, and it supports a massive variety of enterprise data sources, including Oracle, Microsoft SQL, IBM DB2, SAP, PostgreSQL, and it doesn't matter if these databases are hosted on premises or in a private data center or up in the cloud. HVR can tap into those logs efficiently. Now, the second pillar is integrate. Once HVR captures a change, it needs to write it somewhere, right? So HVR can stream this data into modern cloud data warehouses like Snowflake or, as I mentioned, Amazon Redshift, as well as in other relational databases. Now, what makes HVR unique here is its ability to automatically map data types from the source to the target seamlessly. Okay, it can map the data types automatically. Now, that too.
Yeah. So wait a minute. So we are having a problem here. So we have a source tables and we have a target tables. So my precise question is that to have a successful replication, does the source data type has to be same as the target?
Can you repeat your question once again?
So, for example, I have a table as I have a table like name, and then the source name and the target name. In the source name, does the data type of that in that there will be columns like name, social security number, address, zip code, and all. And in the target, the data types are not same. So, for example, in source it is varchar 100, but in target it is varchar 30. So my question is that will my replication fail if this happens like this, or it will be successful?
So very first thing is like when we set up the replication, okay, let's say you have source, let's say you have source database and you have some tables in that source database. Now these tables, before establishing channel between source and target database, these tables does not present in your target, right? So when you set up the replication and when you start the replication or when you load these tables from source database to your target database, how come your
so what your precise answer is that my source and database has to share the same data types.
Yeah.
That's what your answer to that is? Okay.
Yes.
Okay. But I did think that even if it is 100 at the source and 30 at the target, without giving an error, it should do it. It might not give me the complete name.
Unless
is that a right assumption?
Yeah, unless and until it is under your limit. Let's say, for example, let's say on your target you have defined a constant as varchar 30 and you are sending data of varchar 100, that definitely gonna cause error, right?
Okay, so it will false an error. So in that case, if it will false an error, will it replicate or it will not at all replicate and will stop in the beginning itself? That's what
it will throw an error. See, the beauty of HVR is every time you will see a different type of error.
Okay.
So
Is
you
it a
will say
beauty or it's a pain?
beauty and pain, both of the things.
Yeah, I would
Because
prefer if it's same every time, because then I know how to solve. But if it's every time different, then I have to be really prepared.
exactly,
Yeah, yeah.
believe me, you're not going to get similar error. And even if
Okay.
you ask me, like, explain me some errors, even
Hmm.
if I dig out some list of errors and share it with you, that's not gonna
Yeah.
help you, because every time the source will be different, target will be different, scenarios will be different, data
Hmm.
will be different, data types will be different, right?
Hmm.
The infrastructure will be different, so you will be dealing with a number of different types of errors.
Okay.
So yeah, so
Okay.
uh,
So another thing is that what is a channel here?
I'll be explaining everything.
Okay. Yeah. Please go
Yeah,
ahead. Go ahead.
channel is not agenda for today. Okay,
Okay.
I can finish everything in one day, the whole HVR and all. Okay, I
Yeah.
can do
Yeah.
that,
Yeah.
but
Uh-huh.
let's go step by step.
Yeah. Yeah. Okay. Okay. Go ahead.
Yeah.
Go ahead. Yeah. Yeah.
Okay, so coming to our pillars. So first, capture. We explain. I just explain you. Integrate. Coming to the integrate. So once HVR captures the change, it needs to write somewhere, right? So HVR can stream this into modern cloud data warehouses, like Snowflake. I guess I explained this. Okay, integrate was explained. Now the third pillar is refresh. Now, before you can start streaming changes in real time, you need a baseline, right? So if your source database already has 10 years of historical data, for example, and you can't just start reading today's logs, right? So you need that historical data in your target database. Now, in order to do that, we have this functionality in HVR called as a refresh. So what we do in refresh is basically, when you create the channel, you add the tables in the channel, and we do the historical sync. When it comes to Fivetran SaaS, we call it historical sync, and when it comes to HVR, we call it refresh. So when you refresh the table, all the historical data sitting in that source table gets replicated into your target database or target warehouse, whatever it is. And after that, we will activate the replication, and from that particular time, we will try to keep both the endpoints in sync. So let's say I had 10,000 records in my source database. I refreshed the tables. 10,000 records got transferred into my target database. After that, I'll be activating the replication, and every single record after that, after those 10,000 records getting inserted into the source database, should be part of my target database as well. That's what we do, or that's what we make sure as part of replication. Okay, so
Yeah.
that's the
Yeah, I have a question here. So for example, I have a banking system. Okay. And
Mhm.
the data keeps coming from the source to target all the time. So what would be the scenario if I have to replicate 100 tables? Like, so for example, 100 tables have, each one has got 3 millions. So how
Mhm.
would I replicate, like, do I have to take an outage first to do the refresh? Because I will not be able to do 100 tables immediately. You understand my question,
I got your
right?
question, but
Yeah, yeah.
3 million records is peanuts
No,
for
not 3 millions.
HVR.
I'm saying like
Yeah,
there
I
are
got your
100
question.
tables and 30
Mhm.
30 millions are there. It's a humongous database. Say for example, it's a data warehouse. So
Yeah.
how would you handle that scenario?
Okay, so for that, what we can
Hmm,
do is
hmm,
depends on what kind of environment you're working. Let's say if
hmm,
it's your let's say if it's your development environment, you can
hmm, hmm,
simply go ahead and refresh tables one by one. Okay, one either you can schedule the refresh of the tables. We have some functionalities to schedule the jobs as well. Either you
hmm,
can schedule the refresh of the tables. Let's say batch of 10 tables. Okay,
hmm,
if tables are really humongous, we will always try to split the tables, okay, in a batch, in some batches.
hmm,
uh, And if it is a production environment, and let's say you are working in a prod environment, so multiple times what happens is the data flow will be like data will come from your source. The users will input the data into your source database. HVR will capture the data from your source database and replicate it to your target database. And from target database, some downstream jobs will be running, right? So it's not that the target database is not a hard stop. Maybe maybe some Power BI report is running. Maybe some DBT scripts are running. Maybe some other, let's say, if it's a file-based target, for example, Amazon S3 is your target. Some glue jobs might be running. So in that kind of scenario, you will ask for downtime because you are refreshing the tables, and all the teams should be informed that we are performing the table refresh in this particular window, and you can take the downtime because eventually their downstream jobs are waiting for the data, right? So yeah, if depends on the environment where you're working, it's always good to take the downtime.
Yeah, because the other problem with DB2 is that if I'm loading the data into the target, the table is unavailable. Right? Yeah. So in that case, say for example, I started the process at like today I took an outage. Okay. So 9 o'clock I took the outage. Okay. 9 o'clock, it takes 3 hours to load my target table. So what will happen to that how it will decide which point of sync it will have, and how will I get the 3 hours data which I have missed after the load? You got me? So maybe it's a like
I got your question. I got your
advanced maybe advanced, so we might cover that, but that is a real scenario which I have to work on. Okay.
So to make sure that you just need to select one option while performing the refresh. Okay, that is called as maintain the online consistency or something. It is I don't remember the whole exact name of that option, but when you perform the refresh, you can ask HVR to take care of the changes that happen during the refresh window. That can be taken care of.
Oh, okay.
That's what your question, right? So let's say, for example,
So wonderful. So that means for 3 hours when my data is replicating, it will hold that data. It will hold that 3 hours data somewhere in the queues. How will it work?
Your capture job is running 24/7. Okay.
Correct.
So even if your refresh job is running, when the refresh job runs, the integrate job goes into suspend mode by default, just to maintain the consistency on the target side. Because if reintegrate and refresh runs at the same time, we might face the data inconsistency because capture is also sending the changes, refresh is also loading the data, so that's not gonna happen, right? So whenever you run any refresh job in a channel, integrate job goes in a suspend mode, and when your refresh job is running, it is capturing the historical data till the current point. But even let's say if between the window of refresh, if users are loading the data into the source, we don't have control over that, right? So HVR can take care of that, and also your capture job is running 24/7, and it is also accumulating all the changes. And for that, you have now your question was like, will it store those changes somewhere? Will it accumulate it? Yes, it will accumulate. HVR needs to have a separate repository database for that purpose.
Oh, okay. So that means it keep putting that data into some kind of metadata or hub data?
Exactly. As part of the metadata tables,
Hmm.
it also maintains its own replication internal tables, and also it will
Hmm.
accumulate
Hmm.
these changes in its repository database, or if you have configured any intermediary
Hmm.
database or something, yeah, it will accumulate.
Okay, wonderful. So that's a good thing. So that means, say for example, my 30 million load is getting there, and it's keep writing that metadata table. So I would like to see that metadata tables naming convention. Okay, I know we'll get there later, but I would be really interested in that metadata tables and how to handle it and what to do. Okay, now you can
Uh,
move ahead.
to be
Yeah.
very honest, see,
Hmm.
HVR's hub repository database and metadata tables are not things to touch. Okay, even
Okay.
Fivetran does not recommends it, uh,
Okay.
and it will. I mean, even if it's accumulating those changes, it won't
Mm-hmm.
be that readable or useful for us. It's for HVR's internal
Mm-hmm.
processes. Let's say,
Okay.
for example, HVR will
Huh.
just keep the track of, let's say, for example,
Hmm.
so let's say HVR is replicating some changes. Let's say it meant
Hmm.
to replicate 10,000 records. Okay,
Mm-hmm.
it replicated 9,999 records. So,
Correct.
and let's say something went wrong, or let's say you
Mm-hmm.
ran the refresh in between.
Mm-hmm.
So, in order to keep the history, or in order to keep the track, HVR will maintain the state tables. I'm just telling
Okay.
you one type of table in HVR's internal table called as state tables. Now,
Okay.
the function of these state tables is to maintain the state of the replication. So you won't be able to get much information from that, but HVR knows. HVR, based on the state tables information, HVR will know that, yeah, I replicated data till this point, and after the failure scenario, or after the refresh, or after any point of any point of failure or something, whatever meant to stop the capture job or integrate job, it will
Mm-hmm.
start from that particular point. So that's how it works.
Okay. Wonderful. Wonderful. Okay. Yeah. Yeah. Please go ahead. Yeah. Yeah.
Okay, so that was the refresh. So in refresh, there is one more concept called as slicing. Okay, slicing is nothing but, let's say, if you have a very large table,
Mm-hmm.
and if you directly start the refresh of that table, that might take decades to get loaded, or
Mm-hmm.
that might just go in the state of hung. Okay,
Mm-hmm. Mm-hmm.
so in order to avoid that, or it might, or the memory might it might go out of memory. The jobs
Mm-hmm.
might go out of memory if table is very huge. So
Mm-hmm.
to avoid these kind of scenarios, we have a concept called as slicing. We will surely look into that in our coming lectures. Slicing is nothing but, we ask HVR to load data into slices, just to make the task easier, just to make sure that HVR does not go in a capture job, or integrate job does not go in a state of hung.
So that
Okay.
that you are saying, because less latency in that case. So you are saying, if I have a 2 billion table, you will ask HVR to go through like 50 million each, so that it takes 50 million and it replicates. Is that what you're trying to say slicing will do?
Slicing is nothing but, we will slice the table. Let's say, for example, I have 10,000 records. What I'll do,
Mhm.
I'll make slices of 1,000 each. I'll make 10 slices,
Okay.
and that will help HVR to finish the data load faster, nothing else, and without any issues.
Without any latency, less latency?
See, is latency is referred to capture and integrate jobs. Okay, not
Yeah, yeah.
refresh jobs. So
Yeah.
Latency is always referred to capture and integrate, not capture, to integrate jobs. So you'll always see the latency in front of the integrate jobs. Now, if your refresh is taking a lot of time to complete, your integrate is gonna cause the latency.
So it won't help me in slicing, will not help me in integration. It will only help me in loads. That's what you mean, right?
You mean slicing? Yeah,
Yeah.
see, slicing is a part of performance tuning. Okay, slicing is a part of improving your refresh jobs performance. If
Okay.
it's very simple, don't make it complicated. It's very
Okay.
simple. Let's say I ask you to lift 100 kg of let's say fruits. Okay, if you try to lift all the 100 kg fruits in one go, it will cause some issues to you, right? It might break your spine, or it might cause issue in your stomach, right? So just like that, what we are trying to do here is, let's say we have a huge data in HVR. We will not ask HVR. If now it's your duty to check what is the size of table with the source team. Okay, so if source team says that this table is very huge, then you will go and just simply use the slicing option, just to make sure table gets loaded fastest as possible and without any issues. And as while refreshing, our integrate job is in suspend state, we don't want to increase the latency, right? So just to make sure integrate latency does not increases, and the refresh also gets completed within time, you can use slicing.
Okay. Okay.
Let me know if you have some confusion. I can clear it.
Yeah. Maybe I will have it later, but right now I understood what you're trying to say. Okay. Yeah.
Okay. Now we have a next pillar of the HVR is compare. Now let's say you refresh the data, you started the capture and everything, okay, but you want to check the data integrity. Is my target and source are in sync or not? If you want to do that, you can use the compare feature of HVR. So compare have two types. Okay, one is a checksum and one is a row by row verification. Table checksum is nothing but do you know about what is checksum operation? Checksum, we calculate the checksum, right? Checksum of table. So it will just calculate the checksum of the source and target database, and it will match the checksum. If let's say checksum is matching, then your data is in sync. If checksum is not matching, then your data is not in sync. And row by row verification is nothing but it will verify each and every row with each other. We don't use that option.
Yeah, because it's very time consuming.
Lengthy and
10 billion rows. If you have to do a row by row, it's a lot of problems. So what do you suggest for enterprise to do? Like do the count stars? Will it help? But it's always it's always happening, the replication. So how do you go? Like you have to write your sequels so that the like
nothing. It's just
no.
You have you need to run the compare job. Okay, so basically just the way you the way you ran the refresh job in the HVR, you will simply run the compare job as well. You can simply run the compare job, and compare job will take care of everything. The way, I mean, you're saying that the transactions.
Compare will take so much time for humongous tables.
It might take some time. I agree. In compare as well, I guess we have some options to
Oh, you can slice in that, like you can say compare first 100,000 records or 10,000 records, or giving some timestamp.
Actually, to be very honest, I haven't used the compare feature much, okay, because because so I can check that for you that
Yes,
if we
yes,
have.
please do that. Yeah, please do that so that I can make right decision. If comparison has to be done, can we pass in comparison? So I would like you to look into two, three things. Can we
Mhm.
pass some kind of timestamp start and timestamp and in comparison, or record number like compare from 1 to 100?
No, not
Uh,
like that. Not like
huh,
that.
hmm,
So it
okay.
will compare. It will calculate the checksum of the table. As I told you, we cannot write this kind of conditions in the compare. It's very simple and straightforward feature. It's just
Okay.
that it will calculate the checksum of your source table. It will
Hmm.
calculate the checksum of your target table. Let's say source table checksum is 100 and target table checksum is 99. Then your table is not in sync. Then you need to dig out like.
Yeah, but I have a problem here. Say for example, there is, because I have such humongous tables, my latency is there right now in database. So my source is 100 and target is 50. So how can I compare?
So if your source is 100 and target is 50, then you this concludes that your source and target are not in sync. Now, what the next step? What you can do is
Hmm.
you can refresh the table.
Yeah, but we can't. It's a banking system. We can't refresh such humongous table, and there will be latency of say always 20-30 minutes, and it's been it's been considered, and it's been written as SLA that it's a correct thing. So in that case, how we will compare? We can never compare. So that's why I was looking, if there is a timestamp, I can say morning morning 12 to 5 o'clock I got 50,000 records, and morning in target I got that. Although I'm comparing at 9 a.m., but I know somewhere along the line the once the latency is at zero, it will be replicating everything. But right now it's not doing because there is so much of data moving in so many tables. You understand me? So how does enterprises do that comparison in that case? Like
Okay.
I just want your insight. Like,
Okay.
hmm,
I'm not sure if I've got your question or not,
hmm,
but
hmm,
I think
hmm,
you're thinking very much on this compare feature. So one
hmm,
thing I can do is I can.
hmm,
So you mean to say if we have, can
hmm.
we enter or can we do some conditional comparison over here?
Yes,
That's what your
yes,
question is, right?
yes, 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 yes.
So I can do one thing.
Hmm,
I'll just today I'll check the compare. I'll try to run some compare jobs, okay? And
hmm,
I'll check if we can do the conditional comparison. Let's say, for example,
hmm,
based on the timestamp you're saying. Let's say, for example,
hmm,
you want to compare the data from 9 a.m. to 10 p.m. only, right?
hmm,
That's what
hmm,
you're
hmm.
trying to say.
Right,
Okay.
right, right.
Okay.
Hmm,
So I can check this for you. It's just that. I haven't got chance to work on this kind of scenario or
hmm,
so I
hmm,
mean I'm not working with that kind of use case,
hmm.
so I'm not sure about this. I can check and let you
Yeah,
know
yeah,
on this.
no problem. Yeah,
Yeah,
we are going to be talking to each other for long, so that's okay.
yeah,
Whenever
no
you get
problem.
it. Yeah.
So these are our four pillars. Okay, these are four things that matters the most in HVR. It's your
Mm-hmm.
capture, integrate, refresh, and compare. Okay,
Okay.
so these are your four pillars.
Okay.
Now it's like as I mentioned, as we discussed the use case, right? So why do we
Mm-hmm.
need the real time data?
Uh-huh.
It's just to eliminate the stale data. So traditional batch jobs or ETL jobs used to run at the night or at the downtime. So there might be the possibility that business decisions are being taken on the stale data. So to avoid these things, we have this live data capture, or we can call it near to live data capture. The moment
Mm-hmm.
data is inserted into the source database, it is getting replicated into your target database. So there is no chance that we are looking at stale data and stale reports. Okay, so that's what it says. HVR provides a continuous stream necessary for modern live dashboards. Okay, so this is a simple comparison between your batch ETL jobs, micro batching, and Fivetran HVR. Just we discussed, like let's say, for example, your scheduled ETL jobs might run at the night, or let's say in the downtime, and your micro batchings can run, let's say, in 15 minutes or something. But when it comes to Fivetran HVR, within sub-seconds, your data is getting replicated into your target, and that's what it says. HVR provides a 99% reduction in data latency. Yeah, now this is zero downtime migration. So what it says is, move massive on-premise databases to the cloud while systems are active, and HVR keeps your source and target in perfect sync until the moment of cutover. Okay, so imagine an enterprise is moving their massive on-premise database to a cloud infrastructure. Okay, so they cannot afford to turn off their systems for, let's say, days or 24 hours or some days, right, to copy the data. So with HVR, you can just, parallelly set up your replications from your old on-prem database to your new cloud-based databases, and HVR will keep them perfectly synchronized in real time, while the other replications or other platforms are running in the backend. That's what this slide wants to convey.
Okay.